Good evening. My name is Edmond Kujufosu, and today we'll be doing chi-square test. At any moment in time, if you have any question or anything to say, you can stop me, ask me, Edmond, I don't understand this. What is it? If there's anything you want me to explain further, feel free. At no point in time should anybody interject someone who is speaking or asking this question. Every question is important and everything is very relevant. People have different way of processing things and actually understanding things from a different perspective. And their questions may actually kind of help somebody who may have it in mind, but is not being able to ask or is thinking about it. So you have to make room for everybody to be able to ask any question. And any question that pops into your mind, ladies and gentlemen, ask them. Ask them, okay? It's going to help you understand better. And the only way you can understand better is asking questions, okay? And I need you to do that. I want 2 volunteers to raise up your hands, and then I can make you a co-host. If there's too much noise or a particular background, you mute for me. If your microphone is unmuted and your background is not noisy, I basically have no problem with you unmuting yourself. I repeat, I don't have any problem with you unmuting yourself. But if your background is noisy, I'll admonish you that please kindly mute your microphone, okay? And turn all your videos off if you see that your background is not a place that you want to kind of show in the video. Please kindly turn your videos off if that is so. In relation to what we spoke about, the video for area under a normal curve is already on the YouTube channel, Kodefosu Inspire, including linear regression, crossed up. But saying some of you were saying that you still had a problem in having to deal with that crossed-up analysis. After the chi-square, in 10 minutes, having to deal with the crossed-up analysis only for you so that you'll be able to.
So, what's idea?
And then,
So,
thanks, thanks for drawing my attention to some of the challenges or things that you feel you may not understand. Then that is the best way to go about it, and this is how you learn. In the mix of my video, you're going to have basically just a 1 minute 30 seconds video commercial of basically some colleagues of yours who are engaged in certain businesses, which I feel if you also have the purchasing power and then you need certain commodities which they already have, I'll actually kind of ask you that please, you can basically buy from them. We had one of your colleagues who was able to engage another one for delivery, and he did a very great job. So thank you very much. So today we are dealing with cross tabulation. Sorry, chi-square test. Sorry, we're dealing with chi-square. So we are learning the chi-square test. So the test helps us to check whether two category or categorized variables are related. That is what basically helps us to do. And so, for example, we may ask that as a party vote related to region, we may ask as a country related to the level of foreign direct investment, right? And then we're looking at the main idea for you over here is that we are comparing the numbers we actually see in the table, right? With the numbers we would expect if there was no what relationship. And the numbers we actually see in the table is the observed frequency, which we'll talk more about in the subsequent slides. And the numbers we expect is called the expected frequency, right? And the main formula for the test is what? X squared is equal to your sigma, which is summation, right? Summation of what? Offered frequency minus expected frequency bracket close squared divided by expected what frequency. And these are the terms around it. And then today's lesson is focused on, as I'm saying, the meaning of what of chi-square is, what HO and HA means, which is hypothesis now and hypothesis alternative, what these particular ones mean, expected frequency, working sheet, decision rule, and conclusion, what all these particular terms what mean. At any point in time, if you feel I'm going too fast or I'm talking too quick, kindly draw my attention and I'll basically kind of what, slow down for you to get what exactly we are doing. The focus is to make sure that you understand. So if there's any question too, you can stop me anywhere and then let me know. But in a few minutes, 1 hour, 30 seconds that we go on, Bella Vines can get you watches, perfume. So you can take up the phone numbers and then reach out by Instagram or check out her out by Facebook to get to know some of the product available and reach out to her. She's definitely going to get you everything that you basically want. Also, Alpha Shuttle, as you think of going to campus or doing any program, basically you need quality. So don't compromise on that and reach out to Alpha Shuttle to be able to what get you that chili pepper sauce that tastes nice and have a nice what fragrance. Also, sent by links will able to help you get you the best of perfume. You have to smell nice as a man, as a lady. So it's very good that, or it's very prudent on you to make sure that you reach out to the best to get the best in terms of having to smell what nice. And when you think of cakes and you think of samosa or any of these products, think of EK, right? Reach out to him by the social media handles, check out what he's done, which can help you also reach out to him and be very precise what you basically want. And if you think of if you think of sending something outside to any place, Europe, Asia, thinking of Africa, within Africa, think of DHL Awushi Station, right? Reach out to them and they will do a great job for you. They did one for me and it was an amazing service, right? These are nice people, so reach out to them. And also, when you're thinking of bed sheets, curtains, duvet, any form of these stuff, just reach out to Sewa Sleeping Havens. She'll be able to help you out, see different ones, colors for you to choose from and decide. And Adum Ceramics can also help you with the best of Tom Browns that you want. So you can also reach out to her with a nice recipe that you want, and that will be done for you also. We are thinking of also sewing or the best, think of what Sarat. You can check her social media handle out. She has a lot of nice stuff that she's been doing, and she's going to sort you out. And when you think of a man, think of Kaftan, good wear, think of what GK, right? And reach out to his social media handles. You're going to see a lot of nice stuff there that you can also replicate or your own styles, give it to him, and he'll make sure that it comes alive for you and it looks nice on you. Also, when you're thinking of dogs, which are the best pets, you can also get dogs and cats. Even though I have a bias for cats, reach out toward him forward for businesses. You can take up the phone numbers and the social media handles and then reach out. And then finally, in terms of having to do a hamper, if you have a friend's birthday or thinking of people, be very mindful, be thoughtful of what you do. You can reach out to Hampers Gifts and more to help you do the best of delivery, what package to your friends, which they're going to like. And if you're thinking of cleaning services, just do DCK cleaning services. They're going to really help you out. And then heels to toes are going to do a very great job for you and get you the best heels or the shoes or whatever you want. So please kindly reach out to them. Thank you very much. As we continue, we want to know what at all is chi-square. What is it? So we're saying that chi-square is used when we want to know whether two variables are connected or related. Don't be worried. I'm talking a lot of I'm speaking grammar. There'll be the board as we always do it. I'm going to solve them, explain them. But one thing I want you to understand is I want you to understand why we are here. I don't want you to be like, okay, you've seen the question. Then we go here, start by this, start by that. Understand why this and what these variables are called. What happens, that's why we have A, B, C, D. So I want you to understand the thought process that informs what I'm about to solve for you, right? So that when you are solving or doing something, you have the confidence and understand how it is done. It is better to understand in that context than say, oh, Edmond, I just came to you. I said, just pick your pen. When you see this question, you solve this way. What if an A changes? What if a letter changes or a number changes? You may find yourself wanting. So the thought process to understand is very important that you do that for me. Thank you very much. So as I said, it is used to, we want to know whether two variables are connected or related. And what are these variables? The variables I talk about is what we seek to measure. And then remember what that at this level, I was saying that the variables you basically are acquainted to are dependent and independent variable, which we've already spoke about them already in our subsequent videos and the class. So for example, if we we have party vote and region. We may want to know whether people's region, or like which people's region is related to how they vote, right? And then the chi-square test, we seeks to what? Compare these things as an observed frequency. Seeks to think about looking at what observed what frequencies. Think also about how to deal with what expected frequency. So observed frequency means that the actual numbers in the table, and those observed frequency are the numbers or the values that will be given to you already in the question. That is what we call observed frequency. Observed frequency. And expected frequency means the number we would expect if there are no what relationship, or there are no relation, the expected frequency. So, for example, if the table shows that 80 people in the north voted for the MPP, that 80 is the observed frequency. That 80 is the observed frequency. But after calculating, if the expected frequency is 60, then we compare 80 to 60, right? So the bigger the difference between the observed and expected frequency, the more likely we may have a significant what relationship. Somebody may ask, why is he talking about the significant relationship? We're going to get there. It has to do with the hypothesis that you're going to state, and that the conclusion that will end up having to affirm one of the hypotheses. We'll get there. So going to our next slide, when do we use the chi-square test over here? So in our next slide, if we're talking about when do we use it, is that we use chi-square when the data are in what categories, right? So for example, example of category variables are, listen, party vote. You may have MPP, PNC, NDC, CPP. That is what the category are referring to. Another category may be or refer to, a variable category will refer to regions, Ashanti, Northern, voter. Country, you may have like, Ghana, Senegal. You may have foreign direct investment, which has to do with low or high. All these variables of stuff I've mentioned, definitely I know you're going to encounter one in your examination. So I've basically brought all the modules of this stuff. It can be beyond this, but for you to get what it is. So the important point here is that chi-square uses counts. So if the question gives you a table with categories and numbers, the chi-square is the most meaningful one or useful one to use. I'm not going to talk about what is not suitable because your questions may not look at that, so that you don't get confused, right? I know you've seen these particular ones already in your slides, so I'm not going to just mention them, but we'll talk about them in the subsequent slides. So the key terms in a chi-square question. So when it comes to chi-square and we say key terms, I'm talking about certain things you should know or familiarize yourself with or have a fair idea about. Those are the ones I'm about to explain, all these key terms for you to understand, right? Please a minute, sorry. So I'm going to explain these for you to understand. All the key terms are over here or available here. So the key terms, the first one, which I've spoken a little bit about, has to do with what? The observed frequency. And this is the actual number given in the table. So this one will be given to you in the question. So when we are saying observed frequency, or we quote the formula and we say observed frequency, what comes into your mind? Okay, observed frequency is in the question for me. So I have to go look at the question. That's where I'll get the observed frequency. The expected frequency is the number we calculate using the formula. And then in the subsequent slides, we're going to look at the formula for calculating expected frequency, what it is, right? And the degree of freedom, basically, we find, for example, if you have like 2x2 table, it means that the row -1 and the column -1. And then there's going to be a lot of examples in what we'll be doing so that you'll be able to understand or bring all these things into practice, not in the form of theory, right? So you just have to exercise patience. And then in relation to what you basically do in class or what I've seen you guys acquaint yourself with, you're always basically asked to test at 5%, which is 0.05, right? That is 5%. And how you get the 0.05 is 5 divided by 100 will give you 0.005. And then you're going to look for that on the chi-square table, right? The chi-square table is in the slide somewhere. We're going to look at it and see how it is and how we read it. Since you already have knowledge about how to read area under the normal curve, we're going to bring that knowledge, but we're going to tell you how you're going to interpret it, the figures on the particular table, and how you're going to read it in that regard. Also, S square calculated, which is the test values, the value obtained from what? From the working sheet. And then the S square critical or the table value is the value read from the what? Chi-square table. So these are the terms. You have to read a value from the chi-square table. You have to calculate the S square to get to know what it is. Then the conclusion will end up comparing them. That's when we'll be able to affirm if it goes to support the what? The hypothesis, the now or the alternative what? Hypothesis. And as I told you earlier, okay, then we'll get there. Good. Let's now move to the hypothesis. So you see, when you talk about hypothesis, we're trying to basically make a prediction, right? We are particularly trying to make a prediction. So over here, the question will always ask you, in the question, you're always expected to quote your hypothesis. Then the question is, what is the hypothesis you are quoting? You are saying the null hypothesis usually will say that there is no significant relation between two variables. So which is the first one, which is the null hypothesis, which is written as H2, right? We'll say that there is no relation between the two variables, right? So, and then the alternative hypothesis will say there is a significant relation between the two party and region vote. So always you find that the null hypothesis seeks to reject the statement that has been made, and then the alternative hypothesis seeks to say that there is. So an example of the null hypothesis is what? There is no relation between party vote and region. So for example, we say Faris is the most wise person in Kaswa. Faris is the most wise person in Kaswa. If the question goes that way, so Faris is the most wise person in Kaswa, right? So, or we say that okay, there is a relation between I just want to find a particular example from the question, reframing it to suit exactly the Faris scenario. So just give me a second to get that question. Good. Okay, so when you are asked, for example, do a chi-square test to establish if there is a significant relationship between the level of Faris knowledge, right, and his relationship in Kaswa. So we are trying to find that if Faris is more knowledgeable, is it because he stays in Kaswa or not? Is there, right? So maybe you find that the null hypothesis will come and say that, okay, fine, there is no relationship between Faris and Kaswa's knowledge. And then the alternative hypothesis will say that there is a relationship between Faris and his Kaswa what knowledge. That means he staying at Kaswa has something to do with how knowledgeable he is. On the alternative hypothesis will say, oh, he staying at Kaswa has nothing to do with that. Basically, I'm just trying to use him as an example so you can have just a friendly example in your mind. But we're going to do a lot of examples with different questions, so don't worry about that. So the writing guidelines I want you to employ or put in mind is that use the exact variable in the question. Always use the variable from the question. So if the variable is saying, if the variable over here is Faris and Kaswa relation or Kaswa resident, use Faris and Kaswa resident in having to what to explain the exact what hypothesis. Don't go and pick something else. That's why we say we mean that always use the variable from the question. Always use the variable from the question. Please, those who are the co-host, if there's a background for somebody that is noisy, just kindly mute the person so that it'll be easy for me to kind of just do the class, okay? And please, when you join, and if the person joins and maybe you still cannot mute the person, I think you just have to put the person in the waiting room or remove the person for the person to rejoin. Okay. So always use the variable from the question. And what are these variable? The variable over here was varies, maybe casual knowledge. Use that. If the variable over here is if the variables here, for example, good. Let's go back to the same. The variable here is party vote, MPP, and use that. If the variable here is region, and then you have the use that. If the variable is country and residence, use that. If the variable is foreign direct investment and then its impact, use that. So use what has been stated in the question. That is what you are being asked to do. Use what has been stated in the question. Please, do you get me?
Yeah.
And then I'm saying HO says that there is no significant relationship, and HA says there is. The reason why I'm saying this question is one of the most easiest is that almost 7 steps, but almost four of it you are basically just quoting something, and you are not solving anything. Maybe some of you are not getting, but by the time we are done, you understand why I'm saying it's one of the most easiest one to deal with. Then we go to the two formulas you must know. The two formulas you must know in this. As I told you, that there are some formulas you have to know, but these are the only two formulas that are very, very important that you must know. That's why I'm saying this is quite easy. So there are two formulas in chi-square that is very important that you have to know. The first formula is for what? The expected frequency. Remember that I mentioned expected frequency. Then the question you ask yourself is that how do you end up having to solve the expected frequency? How do you end up getting the values for expected frequency? Then it says that to solve for expected frequency, it is what you are going to use your the formula that you have over here has to do with what? S square is equal to what? Look at something. The test statistics is S square is equal to sigma OF minus EF squared and blah blah. The question is, we don't know EF, so we have to find for EF. So the formula to find for that EF is what? Row total times column total all over n. The number of total for that particular portion. And we're going to draw a table and do that, and you're going to get it very well. Okay. But that's what it means. So you first compute the EF for every cell in that particular cluster. Then you compare the OF and the EF in the working sheet. Then the final total of the last column is the calculated chi-square value, right? And you're going to do that very well. You're going to get it. It's very easy. So don't really stress yourself or worry about. Just keep. You can put this particular formula in your head. These two formulas: row total times column total all over n is expected frequency. Then the test statistics is what? Is sigma bracket open OF minus EF bracket close squared all over EF. And then maybe when you go online, you're basically going to see like six steps. But I've written step 7 because your slides informed 7 steps. That is very important that you take notice of what it is in your material. So it is within the circumference of that. Step 1 says state HO and HA. And I told you that the reason why this is very easy is that step 1, you're only stating O. You are not solving anything. You are only stating. You are not solving anything. Please, I hope you're getting me. State it. That's the only thing you're doing in step 1. Step 2, write the test statistics. You're only writing this formula down. When you write this formula down, you've done step 2. When you write the hypothesis for step 1, which is okay, there is no relationship between foreign direct investment and country investment. There is a relationship HA. There is a relationship between foreign direct investment and country investment. You stated it. You are done. Number 1 is done. The first step is done. You've gotten your marks. Step 2, we are going to write step 2. The test statistics. S square is equal to sigma bracket open OF minus EF bracket close squared all over EF. Step 2 is done. So out of the 7, you've just done 2 steps. They're out. They're done. Then you move to step 3, right? Which has to do with what? You are computing the expected frequency. You're now about to find the expected frequency, which is what? EF is equal to row total times column total all over n. As I said, we're going to solve, we're going to show how we're going to deal with that. And you're preparing a working sheet. You're going to also deal with how you're going to deal with that. Then step 5 will tell you find degree of freedom and read S squared from the table. So degree of freedom is very simple. The number of row and the number of column that we have minus 1. That is all. Then you find what the answer you get, you go and find it on the table. So the 5 is also a very easy one for you to deal with. Then step 6, you are only going to state for what you have in your, according to what you have in your slides, you're only going to state what the decision rule. Some online, this one will not give you to state that because they feel like you're going to do a 7. But I said you're going by your the format. So you're only going to state what the decision rule, as in what is already written down. That if x is bigger than higher than x is more higher than this, we are going to accept it or reject. We're just going to state that we're going to have that particular statement down. That you are going to just state that particular statement that accept HO if S squared calculated is less than S squared read from the table. Reject HO otherwise and accept HA. That is all. That is what you have to write for step 6, and that is all. You are stating the idea that is going to inform your conclusion in step 7. And step 7, you only conclude, but you are going to affirm. So, for example, since the calculated S squared is so and so is less than the S squared expected from the table of 3.841, we accept HO and then we'll conclude that there is no relationship between party vote and then this or foreign direct investment or that, and that is all. And you're done. 2 or 3 lines and you're done. So technically, where you have to compute stuff will be around your 3, 4. But in between that, your 3, 4, the rest are all easy stuff for you to do. And when we start doing that, you now come and appreciate the reason why I say the chi-square is also one of the most easiest questions you can do or deal with. And then when we are solving, we'll come to use this particular table, how to read the chi-square table. As I said, since you already have some knowledge about this in terms of area and the normal curve, we'll bring it here. So if after you are done with the number of table, the row and column, and then you subtract it from 1, 1, and then your final answer, let's assume your final answer is 3. It means that the degree of freedom is on this side where you see me pointing the arrow. That's why you're going to read the 1 hour to 30. So if it's 3, this is 3. Then the 0.5 that you're talking about is on top over here. Sorry, it's on top over here. So you're basically going to look at on top over here. You see 0.5 here, where the red sign, where my arrow is here, 0.5. Then you're going to trace the 0.5 to meet the 3, where they will meet their intersection, which is 7.1815, is where you found your answer or where the answer is. So I want us to write the answer for this. I want us to look for 1 on the table as against 0.5, 5%. If you are testing at 5% and we are going to read 1 from the table, who can try for us? Let's assume we solved the degree of freedom and then we had 1.
3.841.
3.4841. How did you come by that?
For the 1, starting from the 1, I dragged it to where we had a 0.05.
Good. So that means she dragged it from this is the 1. He identified the 1 over here, degree of freedom, and then came to this line, which is 3.841 over here. This is where she got her answer from. So we're just going to use this principle as and when we do, but this is how the table is read. This is how the table is read. Right, so you're looking at where the row and the column would meet in the critical value. This is where, so that's how she got her answer over there. And the decision rule is that if S squared calculated is less than S squared from the critical area, reject HO. If it's greater than, you accept HO. So we're going to look at all this and you're going to write all this. We're going to look at all this, how you're going to mention that or state that. Is very easy. And then this is the table also. We may come back to this when we are solving on the table. We are doing the actual solving on our table or to get to know what it is. And then how to write the conclusion well. So a good conclusion must compare the two chi-square values. And I'm going to come back to this when we get to the conclusion. So now I'm not going to talk about this. We'll come back to this when we get to the conclusion, right? This is our first question we are going to deal with. This is our first question we are going to deal with. So I'm going to pause over here. I'm going to bring out the screen. I want you guys to take a screenshot of this question, this screen, right? When you are giving the question, the truth is that there is no row total and there's no column total. I placed them here because I wanted us to kind of solve them and add them over here, but we're going to solve that or do that on the screen. Okay, so don't worry. This is basically more like a question. So please, someone, are you taking a screenshot of the question?
Yes.
Good.
Yes.
Someone is definitely going to read for us. So now I'm turning this off. As I move, as we're about to solve, if at any point in time you think you're seeing something is not clear, or you think you're seeing stars, let me know so that the stars become things that you can see clearly for yourself. Okay. So let me just do this in a minute. Good. Our pen is in. Everything is set. So when you can see the screen, please just let me know if the screen is visible for you to see. Then I do that. Can you see the screen? Nice, brilliant. So
active. We see it.
thank you, George. So let's move to the question. Can someone just read the question out for us? We have 3 questions in all, and then
The following is a crosstab of the relationship between region and party votes.
okay, yeah, continue.
Do a chi-square analysis of the relationship between the region and the party votes. Test at the 5% level.
Okay, so you've been given a table, and then you've also basically been asked to test something at what? At a 5%, right? So you've been given a table, which is very important. You have test at 5%. So now we are going to use the same thing or the same assumption, but this time around, we're going to solve it around the concept of what? We are going to solve this around the concept of a chi-square. I think I saw one here that was. So let's move this now to chi-square. I'm sure there's a question you may have seen before, but I'm just, some of you may even have the full question already, but this is the question, but I've taken excess of it, and then you're going to use that one to solve. So when you're giving the question, you're basically giving this and this, test at this percentage or test at that, right? And then the first thing you have to do when you are given the question is this. Some of you may decide not to do it, but sometimes I advise that you draw a table. The table is basically to help you to be able to interpret the figures very well when you have your column total, your row total, so that at a point you don't get confused. So the table is just for your own assessment to be able to help you what kind of evaluate what you're about to do or assess them very, very, very well. Okay. So think about that too when you are dealing with that. This has to do with region. So the question itself is the following is a crosstab of the relationship between region and party vote. That is it. So do a chi-square analysis of what between relationship between region and party vote. Test at 5% level. So this is the question. Then the first thing you're going to do is that because you want clarity of it, the question will give you a table. So I admonish you that you're going to repeat a portion of the table, but there's going to be a little bit of an extension of a new column to the table. Reason because you want to break the table down so that as and when you are solving, you get to know where all your values are, and then things are in exact way for you. So I do here region. Keep it in mind because at a point I will be asking you to solve another question, or I mention your name, you tell me this. After I'm done with the first one, the second one, I'll be mentioning names as usual, and then you'll be telling me what the answers are, what the step is, what we are supposed to do for this or do for that. So put that also in mind and pay attention. So when I do this, I come here. You see, the question is giving you to this point, right? So the question is giving you values up to this point. So you may have something like the NPP here, the PNC here. The values are 20, 60, 80, and 40. So you have a table like this given to you with a question on top like that. This is what you're going to have. As in the following is a cross tabulation between country and blah blah, do a chi-square blah blah blah. So you've had something like this. Then you are going to redraw the table again in your answer book. The reason because you'd want to have a full idea of the whole stuff. So here is going to be your row total, and here is going to be your column total. Am I right? Hello? Hello? Can you hear me?
We can
Okay.
hear you.
So you are basically now going to add all the values at the MPP level to the row total, all the value at the PNC level to row total. Come and add all the values under the Ashanti for column total, all the value under the North for column total. So Albert, if you're supposed to add all the values for MPP, right, under the row total, what will be the figure that you're going to get? Hello,
Yeah, sorry.
Albert. Okay.
Yeah,
So
100.
100. Thank you. What about PNC?
100.
100. And then what will be the row total for what you just gave us?
Row total for?
For the row total for the values you just give us.
So it will be 200.
Okay, let's put 200 here. So what will be the column total for the Ashanti?
It will be 80.
80. What will be the column total for the Northern?
120.
120. So when we check, this all amounts to 200 over here. So we have this table. Somebody asks, why are we worrying ourselves with this table? This table is supposed to help us to be able to do step 3 very well when we get to having to look for the column total and row total when we are solving it. That is why we are basically doing this particular step. Then now let's go to the real step 1. What did I say step 1 you do? I said you state the hypothesis, right? So step 1, hypothesis. That is what I'm about to do. Then I write HO. What what was the variables that were used in the question?
Region and party vote.
Thank you. Region and party vote. So if it's region and party vote, then I say HO what always is a noun. It
Eddie,
rejects. Yes.
Eddie, please come back with how we got the HO.
Okay. So as I said, the HO is going to be premised on what the variable the question has given. So the HO is hypothesis. You are trying to just say that, okay, fine, I'm about to start a work. Please, what is your name?
I'm Paris, Doris.
Doris. Okay, so we are about to start something, and what we're about to deal with over here is that we are saying that we should do a crosstab to establish the relationship, or we should have a chi-square analyze the relationship between Doris' beauty and where she comes from, right? So we are about to do a work, but we don't know if Doris' beauty has a relation to where she comes from, or where her beauty has nothing to do with where she comes from. So we are about to state the two possibility at the end of the day. That at the end of the day, we will now be able to test if indeed Doris' beauty is it from where she's coming from, or it's not from where she's coming from. So the first step is only having to state the two possibility or the two outcomes of the situation of what we are about to do. Doris, do you get me?
Yes, please.
So I said HO is a noun. So the HO rejects it. Says that, okay, fine. Doris' beauty does not come from where she comes from. Then the HA will affirm, will say that what has been written there is true. That Doris' beauty comes from where she comes from, or it's because of where Doris comes from. That is why she's beautiful. So we've stated these two possibilities. At the end of the day, our step 7 will come and tell us indeed which of these two outcomes is the truth or is right. Doris, do you get me?
Gotcha.
Thank you very much. So, Doris, come with me. Are you here?
Eddie, I'm here.
Good. The question says, do a chi-square analysis of what of the relationship between region and party vote. Test at 5%. So, Doris, how would you state your first hypothesis?
Eddie, that's what I'm asking you. I don't know how she said something. You asked the question that what is her first hypothesis, and she said something. That's why
Okay,
I said, can you please go back?
okay. So, Doris, do you know the variables that we are dealing with in the question? The variables. I think I'm supposed to
Is
have a
it
question.
party region party vote or
Party vote. Look at the screen. So the variable is this. These are the variables. Can you see my screen?
yes, I can see your screen.
Good. So these are the variables we are dealing with. Do you see it here? The ones I've circled. Hello, Doris, do you see the ones I've circled?
Yeah, yes, I can see.
Good. So what you are saying is that when the question is given to you, the variables that have been given to you is what you are about to. We want to check and see. Say, at the end of the day, are we going to find that there is a relationship between the party vote, MPP, BE, and the regions, or there is no relationship? So then they will be able to tell that, oh, if maybe MPP in Ashanti region, they get lesser vote because they don't like that's not a strong vote. The not many they get higher vote, or PNC they did this. So at the end of the day, it is a final outcome of the 7 that will tell us. But we are going to set the two outcome that if there is indeed a relationship between party vote and then region, or there is no relationship between that. And I'm saying that when you have the variables, the first thing that comes into your mind is that you are going to talk about the null hypothesis. The null hypothesis. The null hypothesis is like it's canceling. It's saying there is no, there is not, there is not, there is not.
Mm-hmm.
Then the alternative is saying that there is. Do you get what I'm trying to say?
Gotcha.
So out of these variables, and how would you quote the HO, the null hypothesis, which is called HO? How would you quote it?
Party votes and region.
Okay, so let me go back to this slice. I'm coming. I'm about to show you a particular slice where we are talking about hypothesis, which is very, I'm coming. Hypothesis. Good. So I'm going off this particular screen. I'll come back. So Rose, can you see the screen? Doris, can you see the screen? Doris.
Pacho, yes, I can see.
Okay, so this screen talks about the hypothesis, and then you want to know how the hypothesis came about. The hypothesis is part of the steps. So the hypothesis we are saying over here is we are trying to give the outcome of what you're about to do. What are the two possible outcomes of what we are about to do? So we are about to do chi-square. We have been given the question. But now the hypothesis is that what are the two outcomes of what you're about to do? At the end of the day, if you are solving the question, say anye AI a baby, anye be mobile or bar. So we are quoting to see, okay, fine. There is a relationship between, there's no relationship between. So he said that HO usually says that there is no relationship between two variables, right? So when you're talking about HO, it says that there is no relationship. So for example, if you have party vote and you have region, then you end up saying that there is no relationship between party vote and region because that is HO. It always rejects. Then if you have, you are stating the alternative hypothesis, you will say that there is a relationship between party vote and region. Over here, step one, you are quoting or you are writing the two possible outcome that this variable can give us. This variable can either establish for us to know that indeed there is a relationship between the parties, their vote, and their region, or there is not. So the question is only be asking us step one to only quote or write this statement down. That is all. Doris, you get me?
Yes, I get you.
Okay. Let's go back to the so the first one we are going to quote or we are going to go as in the two possible outcomes that we can get for this particular work or what we are about to solve. The two possible outcomes that we can get from it is that the first thing is that we are going to state the hypothesis, which is HO, which says that there is no relationship. There is no significant relationship. Oh, okay, relationship. I think you see when I write this, I mean between region and party vote. Then HA says that there is a significant, get to know that you're always using the variables, right? And the variables, we spoke about the variables under crosstab tabulation, and then we spoke about variables also under linear regression. So you basically now know what variables what are. So you're going to just use the variables in having to make those particular statements. That in one breath there is, in another breath there is not. So HO is always rejecting, and it says there is no significant relationship between party vote, region and party vote. And then The HA is saying there is a significant relationship between region and party what? Vote. Please do you get me? Is there any question?
Yes, Eddie.
Okay.
Uh, so does it mean when we interchange the premises, we are wrong? For instance, I say I use there's a significant relationship between region and party vote for null hypothesis, and then I bring the premise for null hypothesis for the alternative hypothesis. Will that make it wrong?
No, if for example, I want to I want to get you right. Tell me if what I'm getting is right. So if you're writing there is no relationship between, let's say, party vote and region, that's what you want to say. You come and write there is a relationship between party there's a relationship between party vote and region. Is that what you're trying to say?
Yes.
So what I admonish you is that since you started that you started, for example, you started by saying there is no significant relationship between party vote and region. When I'm writing the HO, use the same way. There is a relationship between party vote and region. Don't mix them up. Okay, just use what you started with. Just use the same variable arrangement for the second one too. The HA. Is that what you're getting me?
Okay. All right. Thank you.
Yeah. For uniformity and making it nice, just use that particular same analogy for that. So when it comes to step one, what we are just telling you, and I'm just speaking chief for some 2 minutes. Step one, no, the catch one say, there might be a friend variable. Variable no, variable no, idea what question mudada. Any idea ye adwuma, ye pese ye measure ye adwuma. Na sa variable na de ma no, be hwem bi wo na party vote na region. Nti party vote na region ye ka se gina no so. Na fire statement mienu eto ho. Baako beka se there bi, baako beka se ane. The entire year just second you have to want to say, but see, you say at the end of the day, you and there. Second, when you were at Toronto, the end of no cre. Into ye come say there is no relationship between party between region and party vote. A one chain, right? There is a relationship between region and party vote, and also a for that means we are at the end of the day, you do 7 and you be some pa say omo nkita ho die bia na sa party no region vote and also munni. Into the area and be say the try and mu dey no cre. Are we going with? That's what you are just doing for step one. You are just kind of using the variables to make a statement for two possible outcomes of what you're about to deal with or predict. Please do you get me?
Yes, please.
Thank you.
So, thank you, Ray.
Okay, you're welcome. So moving to the next step, which we call, I'm going to talk about step 2. Step 2 says something. What does step 2 says? It says that I remember when we were doing the step 2, it says that you should what? Mention or what? Write the test hypothesis. So step 2. I'm moving from this board. Let's do this page 1, right? Let's move from here. And let's come to page number 2. So page 2, right? And then step 2. Test statistics. X squared is equal to sigma. Sorry, my sigma is not sigma. OF minus EF. I told you that OF is what? Offered frequency, and it's already in the question given to you. Expected frequency is what you'll be solving, right? All over what? EF. When you do this, you are done. I hope you're getting me. Hello? Are you with me?
Hi, yes.
Yes, we are with you, please.
Then step 3. You see why I say this question is very easy. By the time we finish, I know some of you will even take this question. When it comes to step 3, you said somebody's asking a question. I'm listening to you.
Yeah, I'm the one. I'm asking the step 2. So this is all we need for step 2.
That's all you need for step 2.
Okay.
So step 3, I'll come and write computing you can write EF, the expected frequency, or how you want to put it in place, or how you write it that it will fit for you. Okay. I'm just writing in full because you get to know what I've like what is there, so that somebody gets to know. That's why, because I'm teaching, that's why I'm kind of not using a shortcut. So it will be what? EF, which is expected frequency, is equal to row total times column total all over what? N. So we are about to look for what? Calculate for what? Expected frequency. And this is where you're going to rely on the table. The reason why did you let us do the table? Table near the bed then. If you think you don't need a table and you can remember the things in your head, fine. But because sometimes it's quite challenging and a little bit stressful, you may want to kind of use the table so that you would then be able to compare and see what it is. Did you guys take a screenshot of the table? So all
Yes.
of you go back to this table, take a screenshot. I will mention your name one by one. So if you're not taking the screenshot, take it right now. We're going to use the table to solve for step 3, and everybody's going to take involved. Everybody is going to be involved. If you're done taking the screenshot, you tell me.
Hello, Eddie.
Yes.
Sorry, please, I want to ask a question about the table. So, is there a case where the row total and then the column total might be different?
The row total and column total might be different. How?
Okay, so example, let's say Northern was like 60 and then the total was 80. So 80 and 100 will give you 180, right? And then when you come to the column, maybe 80 and 120 will give you 200, like two separate digits. How are you going to go?
No.
Okay.
If you have a question of that sort, I want to see. But for so far in what I'm doing, I'm not saying it cannot be possible or what it is. But since I've not seen it, I'm not going to claim that I do have monopoly over knowledge. But what I've solved, I've gone through so far in the literature, what I've acquainted myself with, I've not come across a scenario like that. It's like solving. I solve a crosstab, and then it is more than 100%, or it's maybe you get 150, you get 110. In mathematics term, it's supposed to be 100%. So for me, it is impossible. I hope you get what I'm trying to say.
Oh, yes, please. Thank you.
I know. Okay, you're welcome. So we are going to go by using this table, right? To go into calculate. Since you've taken the picture of this table, when I call you, I'm going to solve one, right? Do you get what I'm trying to say? I'm going to solve one. Then whoever is next, you're going to answer for us. Okay. So the first thing I'm going to solve, or the first thing I'm going to do, let me make it easy for you guys. Let me write. Let's see. So do I have to write the given totals so that you guys are aware of it? Okay, for teaching purposes, let me write this here. For teaching purposes, given totals. N is equal to 200. Row total is equal to, yes, MPP is equal to 100. PNC is equal to 100. Column total, Ashanti is equal to 80. I'm doing the north in the short form, is equal to 120, right? So these are some of the figures of what we've had on the table, right? So those are the figures of what we have had from the table. So we are now going to solve starting with MPP Ashanti. Anyhow you feel is okay for you that you can really solve it. This is not compulsory to bring. What I've just circled or highlighted is not compulsory for you to bring. I'm putting them there for teaching purposes, right? Or I should clear it from there so you get to know what you are solving for, if how it looks like in examination. Should I keep it or clear it from there?
Keep it.
Okay, so in that instance, we are now about to solve. The first one has to do with what? And the first one I'm about to solve for this is going to be NPP. If you remember, you can write what you have to write. NPP Ashanti. That's what I do. Then NPP Ashanti will be equal to, that's the expected frequency, right? Row total. So now you're going to ask yourself, what is the row total for Ashanti? What is the row total for Ashanti? Listen and look at this very, very well. Row total. And what's the column total for what? For Ashanti. So look at me very well. I'm going back to the board where I'm going to pick my row total, my column total from for the Ashanti, and then the column total for that. So we've gone back to our table, right? So the row total for Ashanti, for MPP Ashanti, this is the row total. So the row total is here. It's 100. The row total for Ashanti is going to be, what's going to be the row total for Ashanti?
100.
100. And what's going to be the column total for Ashanti?
80.
200.
You said
80.
80. So look at this very well. The column total for Ashanti is here. This is where we picked it from. So Ashanti, this is Ashanti. This is Ashanti. Then we are going to trace where Ashanti comes in terms of its column. Column total. Here is it, 80. So the column total for Ashanti is 80. The row total for Ashanti is here. It's 100. And then the column total for Ashanti is 80. Do you see how I got the column total and row total? How we arrived at this? Hello?
Yes.
Yes, Eddie, we get
Do
it.
it again. Or should I do another one again?
Yes,
Let's
please.
move on. Let's
So I'm doing another one, then the rest is going to be you guys. Look at this. Then I'm going to do the column row total for MPP Northern and row total column total for MPP Northern. So when it comes to row total for MPP Northern, the row total for MPP Northern is going to be 100. And then row total for MPP column total for MPP lot is going to be 120. So look at this. The first one we are solving here for what? MPP Ashanti was what? Was 100 and what? 80. So that's the first one we are solving, or the first figure we are solving. To make it easy for you, is 20. So when you take MPP Ashanti 20, the column total is what? Is 80. The row total is 100. When you take MPP Northern, right? You take MPP Northern, right? For 80 over you are taking 80. The column total here is going to be what? 120 like this. Then the row total is going to be what? Also what? 100. Please, you get me?
Yes, Eddie.
Yes.
Let me come back here to also make it more even easier and better. Let me write the 20 here, right? So everybody know what we are solving, right? Is that so? Does this work for you guys? So on the table, I mean that we are solving MPP Ashanti 20. Please, do you get me?
Yes,
And
please.
what we had was what? 100 times 80 bracket all divided by what? 200. I'll call somebody to give the answer for that. Then MPP nothing. Oh, sorry. MPP nothing. MPP nothing will give us what did we say the figure the answer was on the table?
120.
No, for row total is what?
100.
100.
100 times
120.
120 all divided by all about 200 will give us this.
200.
So for MPP nothing, what was the value that we were looking out for? Was it, what was it?
80.
80. So I write 80 here. Let me circle so that you guys get to know where the values are. If you're not getting it, let me know so that I go back home.
Divide the 80 and the 20.
Okay, it's good. Good question. A minute. The 80 and the 20 is not compulsory, but I'm putting it there because of understanding. So let's go back to the table. Because of our understanding sake, you see the 20 over here, I'm just trying to say that we are solving this particular one, the first one, 20 for Ashanti. And the 80, this is where I got it from. So we are solving this particular column. So we are looking for the values on the line for the 20 for both column and row total. So that people don't get confused. Do you get me now?
Yes, please.
You get where the 20 is now coming from. But if I write Ashanti, total, and I come and write North total, somebody may say, okay, where is it coming from? How are you getting me? So to make the understanding easy for people, what I've just done is that you should just know that we are solving for 20, and under 20, the column total for 20 is what? Is 80. Is 80. And then the row total for 20 is what? Is 100. So it's going to rather be 100 what? Times what? 80 all over what? The total here, 200. Do you get me? Then the next one is nothing, nothing. MPP nothing. That is under 80. So under the column 80 is what we are looking for. So now the column, the row total for 80, this same 100. Do you get it? But the column total for 80 is different. It is what? 120 here. So it's going to be what? 100 times 120 divided by what? 200. Do you get me? Hello?
Yes, I get it.
Okay. Please, everybody gets it. Because this one key foundation. You don't get how to read do that permutation, it becomes a problem. You get all. If no, I just do a small rendition of 1 minute of tree or 2 minutes of tree, and then we continue. Does everybody get it?
Yes, I did.
Let me carry on. Okay, so since you all get it, then now it's time to call you guys to give me my next one. So next one, let me just write it down. PNC Ashanti. What's the value we're writing PNC Ashanti? What was the value view? Let me go back to the 60.
60.
So 60 is what we are solving. So I'm going to leave the bracket open for whoever is going to answer. Then PNC North. What's the value?
40.
Thank you. 40. Good. So when I call your name, you kindly respond. Then you tell me what values I'm supposed to place there. Sarah. Let me call those I've not heard their voice in class before. Sarah. Sarah. It is not difficult. So if you're able to embrace yourself and answer, that's when I get to know you basically is getting what you are getting the understanding. If there's a hiccup, we'll then go over, then you understand better. Okay. So you should feel free to be able to answer. Nazel. Nazel.
Yeah, I'm here. Eddie, I'm here.
So under 60, what is the row total for 60? Under 60, what's the row total for 60?
Eddie, please, can you go back to the
Table. Okay, I'm back to the table. Under 60, what's the row total?
80.
Okay, wait. Let's look at the table in perspective. Where do we find the row total? The row total. Which side do we find it? It's here. This side.
Oh,
And
okay.
then
Yeah, sorry.
the row is on this side. This is the row side, right? And this is where we find the column. Okay, so take notice of that. So now under, so which one will be the row total under 60?
The 100.
And good. And what will be the column total under 60?
80.
Thank you. So let's go back to where and put what Nazil said in writing. So he says 100 times what? 80, right?
Yes.
Nazil, you said 80. Okay, 80, good. Which is the column total. Divided by what? The total will be what? 200, which is equal
200.
to,
200.
yeah. So Nazil, thank you very much. Let's move to our next person. Hannah, Jesse. Hannah,
Yeah.
can you give us the values for under 40, the row total and column total? So to be fair to you, I'm going back to the table. So what's the row total? This is the 40. What's the row total and what's the column total for the 40?
So it's 100 times 120.
Thank you.
All
Super.
divided by 200.
That's nice. Good. So Hannah has also made it easy for us. So let's just put what she just said into our entry. She said, Anna, you said what? 100 times what?
100 times 120.
Mm-hmm.
All over 200.
Thank you very much. All over 200. So Anna just gave us that particular answer. And I know all of you now understand how we got here, right? Delali. 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 Delali, you had a question for me this morning when I woke up. So unmute yourself and talk. As I also have a question. Delali, unmute yourself. Or Delali is not with us. Esther Amponsa.
Yeah.
Esther, can you give me the total for both 20, 80, 60, and 40? What the total for all these figures that we just mentioned? Can you give me the total for them?
Please, the answer for the PNC Ashanti.
Yeah, the answer for both MPP Ashanti, MPP North, PNC Ashanti, PNP. So what will be the total for all the ones that we've done? 100 times 120 divided by 200 will give us what? What will be the total for all these answers?
Please, the first one is 40. NPP
40.
Ashanti.
It's 40. Thank you. Mm-hmm.
The second is 60.
The second is 60.
60. Okay. Then the third one.
40.
It's still 40, 60.
40. Okay, 60. So this is how come we've now gotten all our values for what? Expected what? Frequency. Expected what? Frequency. Do you all now get it now for step 3? You see how easy step 3 is? Can we go to step 4?
Yeah.
So at this point, is there any question?
Please, I have a question.
Okay, Clement.
This row total column.
Hello, wait. Clement, when Clement is done, then I take you. So Clement, come in.
Okay, mine is just a clarification. I just want to know the table we generated before starting with the step 1, is it advisable to do that at step 3, since that's where you need it?
Yeah, you can start to do it at step 3. It's okay. There's nothing wrong with that, Clement.
Oh, okay. Thank you very much.
Okay. Please, someone was speaking. Sorry, before Clement spoke before the other one.
This is Daniel.
Okay, Daniel.
Please, so let's take if the independent variables are maybe about 4 regions.
If the independent variable what?
Let's say about 4 regions. You can
you can all the 4.
regions.
Yeah, all the 4. Yeah.
Okay.
Yeah.
Okay, thank you.
You're welcome. Please, somebody was. I think we had a lady speaking before. I think Clement was speaking. The lady came in.
I'm the one.
Sarah, talk.
And this column total thing is very confusing, but I'll be fine.
Okay, so this is it. Let's do a final rundown of it. So we say under step 3, you are supposed to do a row total, column total. Just put in mind that on this particular tangent going this way is the row, and this particular tangent is the column. Sarah, do you get me?
Yeah.
Good. So if you are solving for expected frequency, you are going to use this totals to solve for the expected frequency. So for example, I want to solve for the first one, MPP20, but the formula is row total times column total. So I ask myself, where does the row for MPP20 fall? And the row for MPP20, the total falls over here, 100. And where does the column total for MPP20 falls? It falls on 80 this year. This column total here, 80. So it means that then my answer becomes what? 100 times 80 all over 200, which is this total, which is constant, will be for all. Then I come again to northern region, or you can come here. Anyhow you think it will be okay for you. I come to northern region, party vote, MPP northern region, 80. So I ask myself, what is the row total for MPP northern region, 80? And then the row total for MPP northern region, 80, is this 100. I see here. So that means it is 100 here, right? Then I ask myself, under the same MPP northern 80, when you come to the column total, where will I find it? I'll find it here under 120. So this one is rather what? 100 times 120 divided by 200. Do you get me? So then I come again to PNC 60. This is PNC 60. What is the row total for PNC 60? When I draw my line to where the row total for PNC to the end is 100. So then I ask myself, under PNC 60, where does the column fall? The column falls on what? This particular 80. So now it is 100 times what? 80. Then I come to PNC what? Northern region under 40. The column total, the row total, or let me start with, or the row total for PNC.
PNC 100
is what? Is 100. Thank you. Is what? Is 100. So yeah, what will be then the column total for PNC under 40? What will be it?
120.
120 here. That is how you read the table, and you are good to go. You see how simple.
Oh, okay. I get it now. Thank you.
You're welcome. Yes.
Please, is it always constant that the row total and the column total will have a same figure?
No. When it comes to this particular part, this side, always it ends up being tallying like the same.
Okay.
Yeah, it ends up tallying the same. It's like if you remember you're solving crosstab, realize that if you do this for crosstab, all will tally the same. That's how you're going to get 100%. So you're going to have it in this intersection is going to be the same.
Okay. Please, let's go to the next. My next question is, let's go to the next page.
Okay.
Page 2.
Oh, I also have a question.
So per the table, meaning that we are going to always get same answer and same figure for the second one. Is that not it? Like the MPP Ashanti, the row total and the column total.
You see a pattern of repetitive stuff. So I have 3 questions. You realize that the 3 questions that we'll be doing, you basically see these are all questions that you may have seen before or come across. You see a pattern of repetitiveness in terms of like the first 2 will have the similar, the other 2 will have similar in that order, right? So you see that particular pattern. So the question you're asking in terms of would you maybe kind of see that as possible? There can also be an instance where the values will be it will vary, it will different. It will not necessarily be the same. I'll get what I'm trying to say. I'll solve one question with you on that, where the values will not necessarily be. So that particular one was like 40, 120, 180, 40. That was the same party Ashanti, but when you are solving, you get the row total, you get 200, 160, you get 140, 220, then you come and get 360 at the same time. But the value for the row total differs, and the value for the column total, you see, what we just solved, the value for the row total was the same, 100, 100. You see that?
Good.
Yes.
Good.
But the value for those row total will change. So you realize that the answer that you have for both Ashanti, you have for the MPP, Ashanti, the Northern Ashanti PNC will be different, will not be the same.
Okay.
So you not have that repetitive stuff where 2 answers will be the same, 2 answers will be different. It won't happen. So I've made room for all those possibilities to answer that question already. So it's in the question 3 that we'll solve. And you see that particular change. That's why you're always supposed to solve it, not assume. Because you can have a question where that change can exist. You get what I'm trying to say?
Very well.
Okay.
Thank you.
You're welcome. Please, somebody said you also have a question. Then we'll carry on.
Yeah, I do. I wanted to ask that the HO, is it always negative correlation?
Yeah, so the HO always rejects. So the HO is always rejecting, and then the HA is always what? Affirming or accepting that there is a relationship. Please, are you okay?
Yeah.
Okay. Is there any more question or we should carry on now? Yes.
And I also realized that you didn't calculate with the PNC for the Ashanti. You just wrote 40, and for that of the PNC North, you also wrote 60. You didn't do any calculation.
Or we just wrote the final answer. That's what you're trying to refer to. Hello.
Yes, Eddie.
Are you referring to the fact that we just wrote the final answer? Is that what you're referring to?
Yes. I mean, you just wrote 40, 40 and 40, 60.
No. I'm listening to you.
I thought you were going to do calculation for the 60, maybe 60 times 100 and 60 times 80 over 200.
Okay, I get you. No, you can do that. There's nothing wrong with that. But because of maybe time's sake. So, for example, let me just, for I get your clarity. Let me just give one example. Let's do that. So, 100 times 8 will give us what? 100 times 8 will give us what?
So give us 8,000.
8,000.
8,000 divided by what? 200. Then it will be equal to what? 40. So if you can decide to do it this way, there's nothing wrong with that. Someone also can decide to just put the answers over there. It's also okay. I hope you're getting me. But I get what you're trying to say, and it's totally right if you want to put that way. But to make it easier, that's how we came by the 40. Those who may be wondering how come we got the 40, 60, 40, 60. You understand that, okay?
Okay, thank you.
Is there any more question? Should we carry on? If we should carry on, just give me a reaction.
Yeah.
Okay, thank you, Osman. So now let's go to our next screen, which has to do with number 4. Step number what? 4, right? But you see, for now, what we've done so far, it is a very easy process for you to deal with, right? Step 4, working Please, I hope you guys are not, nobody's sleeping, working shit. Using, please don't sleep, pay attention, okay? And FEF. So step 4 is preparing my working sheet using OF and EF. That is what step number 4. So what we have over here is that, remember that we already have the values for OF and EF now, right? Is that so? Is that so? Do you already have the values for OF and EF?
Yes, please. Yes.
When I call you, you should feel free and answer. Reason being that it helps me to be able to know what the understanding level is, what I should explain, what I should not explain. So you see, when Saram asked a question or was pondering about that, it actually drew my attention that I have to then do a revision of how the column total and the row total would relate. So it's very important I get to get your perspective in what we are doing. That is why I seek to ask you a question. So Bella,
Yes, I did.
give me the values for, do you know the values for OF?
OF.
Which is observed frequency.
Not really, but I think that should be the actual number given per
Thank you.
the political
The
parties.
actual number given to us. Yeah, it's true. Very, very true. You're right. The actual number is given to us. So there's something I want. Okay, so we have this table. Good. As I always say something, I always prefer, if you understand how tables come about, that they don't come out of thin air. So I don't want you to chew any table in your head, Baba. At this stage is difficult because I'm chewing the table in my head. Listen to something. This thing is not part, but I'm writing it here because we're going to use that one to extrapolate or number the table. That is why I'm writing this here. When I'm done, I'll clean it. So what's the what formula have I written right now? What formula have I written right now?
Step 2.
Step 2 formula.
Yeah, the test statistics. The test statistics. So somebody will ask me, you see, we are seeking to find what? Draw a working sheet to find S square. So now we are now about to find the S square itself. The reason why we went looking for this particular value was that, remember that we didn't have this value. Were we given EF? Were we given EF in the question?
No.
Good. But were we given this? Were we given this in the question? Were we given observed frequency in the question?
Yes.
Good. So if we were given observed frequency in the question, that's the ones that were listed for us. We were given observed frequency, but not expected frequency. Now we've gone to step 3 to go and solve for what? Expected frequency. Now we have it. So now we are about to solve using this table to get the final answer for this S square. All along, this S square is what we are looking for. And the formula for this S square is this particular thing I've quoted here. So now to make it easy, how do we end up getting this table? When you look into this formula, what are the terms we have in this formula over here? When you look at this formula, tell me. If you break this formula into pieces, when I say when you look at it, when you begin to break the formula into pieces, what are the terms you get out of the formula? When you begin to break it down, the formula, like you decide, say, yeah, dismantling the formula. Two formula now. Terms gonna be every two formula. Tell me. And then I'm going to mention names. George, let me go to the mail. George.
Yes, Eddie.
What term? Give me one term you see in this formula that can be part of the table. Give me one term that you see in this formula.
We can see OF, EF.
Good.
OF.
Wait, no, step by step. Wait, step by step. You can see OF.
Yes.
So George says that he can see OF, so he can see this. Then we write OF. What else do you see?
We can see EF.
George says he can see EF, so EF. What else do you see again in this formula?
I can see into bracket OF minus EF.
Good. So listen, George can see OF minus EF. This. Let me put this here. So George can see this OF minus EF. This thing. That's what George is seeing. This part. George is seeing this part. So OF minus EF. Right? Oh,
Yes, Eddie.
so I'm coming. This is what George can see, OF minus EF. And remember that all that George is saying is from what? The formula. I hope you get what I'm trying to say. I hope you're getting me.
Yes, please.
Yeah.
Let me clean what I circled. So now, George, what else again do you see from this formula?
I can also see OF minus EF squared.
So George can see this again from the formula. So he can see bracket open OF minus EF back squared. This is what George can see. George, what else again do you see?
I can see the entire formula now. That is OF
Good.
minus EF squared all over
Now,
EF.
George can see all this. So realize that the table you are seeing me draw is from what? The formula. So I have not done anything that is somewhere alien where we've brought a table and I say, oh, chew in your head. This is OF. This is no. This is a table that has been extrapolated from what? From the formula in question. So this is it. All this is from the formula, right? And the final, so this is from the formula, and it's 4. So some of you may want to write the MPP thing and the PNC thing in this one. It works for you. 1, 2, 3, 4. So forgive my handwriting and the diagram, okay. So 1, 2, 3, 4. We had 4 terms and then total. And let's forget that this formula has what? Now sigma. So at the end of the day, sigma means summation. Sigma OF minus EF bracket squared all over EF EF is equal to, then we'll do what is equal to, listen, is equal to, or some of you just write S squared is equal to, that is all. It also works. I hope you're getting me. Any also works. Now I'm coming to, now I can clear this formula. I just want you to understand how the formula, how the table came about. Now, do you all get how the table came about?
Yeah.
Are you okay with that? Good. So now, good. Let's now move to roots. I have 2 roots always in my class, right? Root Akosia.
Hello, Eddie.
So what can you give me the values for the observed frequencies?
There was some for winning your shooting.
No, you don't need to put the table in your head. Oh. You see, the table was done from the formula. Oh. So we didn't put the table in your head. Oh. Or I should go over again for you to see now we did the table.
Okay. I mean, with the OFEF, like, is there a formula that you have to keep it in mind?
No, the OF is just, no, it's not a formula. The OF is values that you have been given. So the OF is the initial value that was given to you in the question. So you see, when I was starting in the slides, realize I told that the OF is what the values that have been originally given to you in the question.
Okay.
And the EF is the one you're going to solve. So the OF, you're not going to solve for anything. Now, what you're going to do is that you're just going to fix the value in, and then you're just going to solve them. You're not going to look for any formula again. So apart from step 1 that you quote your grammar, step 2 you quote the formula, step 3 you're looking for EF, step 4 you come in, draw this table. The table is from the formula. So as long as you have the formula for the step 2, you can just dismantle the formula and then you have the table. Then you just come and put in the values or the numbers that was given to you initially in the question. Then you write them down. You list them down. So that's what Ruth is about to help us with. So Ruth, what are the values for the OF? Observed frequency.
We have 20.
We have 20.
80.
20. 80. Oh, sorry. I think my pen, I thought, so 20, 80,
60.
60.
And 40.
Who doesn't know where all these things are coming from? Do you all know where it's coming from? You know where it's you all know where it's coming from. Give me, if you know where it's coming from, just give me a reaction. Good. Then expected frequency are the ones that we just solved. So that's what I'm about to ask Sarah. Sarah. So I'm about to also ask Millicent.
Eddie.
So give me the values for the EF.
40, 60, 40, 60.
40, 60, 40, 60. So Henrietta Saki. Henrietta.
There.
So we are going to solve for OF minus EF. Do you know the values for OF?
Yes, please.
Do you know the values for EF?
Yes.
So when I say OF minus EF, what does it mean?
20 minus 40.
Beautiful. So let's go. Give me the answers.
20 minus 40.
What the answer be?
Negative.
I'm listening to you.
Negative 20.
Negative 20. Thank you. Negative 20. The next one.
80 minus 60. 20.
20. The next one.
20.
20. Good. Next one.
Negative 20.
Negative 20. Henrietta, thank you very much. Infinix X6725B. Infinix X672. Please, when you're joining, join with your name. Infinix 6X725B. Okay, so now let's move to Linda. Hello, Linda. Esther. Hello, Esther.
Hello, Andy. Please, is it me?
Yes. Esther, can you hear me?
Yes.
So unmute yourself and then give me do you know how we're going to solve OF minus EF squared?
Yes, please.
Okay, so let's give me the answers then for OF minus EF squared.
Okay, so negative 400.
Negative
400.
So good. So Esther, any number that is negative, that is squared, is positive. So nege po. So when you put negative 20 in a bracket, you are going to have a positive figure, right? So then the answer will be
positive 400.
So just 400. What else again? So, well, the rest are all going to be 400, right?
400, yes.
Okay, so Esther, thank you very much. Then we're going to do this. Samuel, Sammy, sorry, Samuel, Sammy. Hello, Samuel. Alex.
Yeah, Eddie.
Please, can you help us with the final one, which is OF?
Eddie,
Yes.
Before that, I'm confused how the OF minus EF square negative 20 is equal to 400.
So in mathematics principle, when you have a negative number squared, it is positive because you are having two negative words. So you're having two negative reactions. As you learn to pop. So two negative together will give you what? Coming together will give you what? Positive. It will cancel itself out. I hope you get what I'm trying to say. Yeah, that is why. So, for example, if you have your calculator with you and everything, just do a negative into bracket, let's say negative 20 squared in bracket. You're going to have what? In bracket, you're going to have what? A positive what number, because they end up what? Canceling themselves out the negative, which making the number what? A positive number. You get me?
Okay.
So please, kindly help us with the figure for this particular one.
For the first one.
Yeah.
The first one will be 40.
40.
Yes.
So the first one is what? Is 40. How did we arrive at 40? If you can give us the thought process.
OF, which is 20 minus EF, which is 40.
Wait. So good.
All
That's what. So now let's wait over here. Under the formula is saying OF minus EF what? Squared. Is Alex, do you see that? So you are going, where do you see OF minus EF squared? Where do you see that?
Oh, okay.
No, I'm saying, where do you see that? You see that, you see, this is where you see the OF 400, good, 400. This is 400. So it's going to be 400, this number, the OF minus EF over here, divided by what? The EF. So when you do that, what will be the answer?
10.
No, let's leave for Mr. Alex to go through.
Yeah, that will be 10.
10, okay. Then the next one will give us what? The next one will give us what? Which will be this divided by EF, this column. What 400 divided by 60, what will be the answer for us?
That will be 6.67.
0.67. Thank you. Then the next one will be what?
10.
10. Good. The next one will be
6.67.
6.67. Thank you very much, Mr. Alex. So as I said, Mr. Alex, if you have any number that is negative in a bracket, it means that bracket, if you are opening it up, it's going to be bracket open minus 20, bracket close times bracket open minus 20, meaning that other day the negative will cancel itself, as I said, and there will end up being what? A positive number, which is 400. Yeah, that's how come we got that. So, Mr. Alex, thank you very much for giving us the answers for these this particular column. Now, and the next person I'm going to call you, you're going to give us a total for this particular session. So, summation, sigma OF minus EF squared all over EF. So, you're going to give us a total summation. A total summation. which means you're going to give us everything, add them all together, and tell us what the final answer is going to be. So that particular one, I call on to Daniel Wusu. Daniel Wusu. Yes.
Please, I think I got different answers for the OF minus OE.
The OF minus OE. Yeah.
EF
Which one did you get? Which one did you get a different answer?
divided by the last one.
So which one did you get a different answer for?
The last ones.
What answer did you get?
I got 100, 44.4, 144.4.
44.4. Is it this? Are you saying you got 44.4 for this? Is it this? Is it this?
Yes. Yes, please.
You didn't get 6.4, 6.64. You got 44.
Yes. 0.4.
Let's do this. Let's do 400 divided by 40. What's the answer? What answer do you get for that?
400 divided by
40.
60.
By 60, sorry.
400 divided by 60.
60.
6.66.
Good. Where you run it over to the two decimal places, you 6.64. So do you get how come you got that answer?
Yes.
Are you okay now? No, if you're not okay, there's clarity you need. Just let me know. Feel free. Don't worry. So I'm trying to show you that's how we ended up getting the answer for this, which was OF squared, minus EF squared. So we picked the values here under this one, then we divided it by this. So when you pick this number, 400 divided by this, that's what gives us this 6.67. It was 6.666, and then we ran it over. So that's how we got this particular.
Yes, sure. I get it now. I was okay. Thank you.
So you get it now. Okay,
Yes.
you're welcome. When you have if you have any number that you feel is off and other stuff, just feel free to talk so that we're able to help you catch up with us also. That's very important for us. I mentioned Mr. Daniel. Mr. Daniel.
Hello, sir.
Please, can you give us the total for S square value? Yes. Summation of all it will be what?
That will be 33.34.
33.34. Okay. So we are done with step 4. Is there any question or is there anything that you guys don't really understand you want me to go over before we move to the easy ones? Step 5, 6, 7 are just easy, and then we're just going to mention them. So
hello. Please, why is it that we had 400 for the OF and the ER for SK?
Okay, the reason why we have that is that you see this is OEF, the one I'm circling. Please, are you seeing it? Madam Doris.
Eddie, please, I can see it.
So this is OF minus EF squared values, and they are minus 20, 20, and all those things. Then now when we get to the next stage, you have to square this value. So we have to square it. So if you square it, it means that 20 times 20 will give us what? 400. Do you get me? Minus 20 times minus 20, or in bracket like this. I'm answering Mr. Alex also question. Will give us what? 400. 400 in a sense, positive 400 in the sense that this negative will cancel this negative. So nege will turn into. Then we can 20 times 20, which give us what? 400. So that's how we got the 400, 400, 400, 400, because all these were 20, 20, 20, 20. And we are squaring them. So we only square this number. We square this. We square this. We square this. Please, you get me?
Yes, please. Thank you.
You get it? Please, is there any more? Is there any more question?
Yeah, Eddie.
Okay.
Eddie, please, I'm confused with how we got the 33.34, which is the latter part.
33.34. So the latter part, what happened was that Daniel added all these values. So we call summation. Sigma means summation. So Daniel added 10 plus 6.64. Then he added 10 again 10 plus another 6.67, like this, equal to will give us that. That's what we have. That's how come we got the 33.34. Do you get me? So pick your calculator. Who asked the question?
Benedicta.
Yeah.
Benedicta, pick your calculator. Do 10 plus 6.67 plus 10 plus 6.67, and let's see what would the answer be.
Okay. Okay, yeah, it's giving me 33.34.
Thank you. That is how we ended up getting that particular answer.
Okay.
Daniel, do you have a question?
Yeah. So, I beg. Yeah. You see the last part. You see, we didn't square it. I was thinking the last part, the last table, the OF minus EF squared. I was thinking yeah. I was thinking about say the squared will come into place. It may be the 10 will be 100, and I am just replacing it.
No, the square is not coming in place because remember you solved the square already here. This is where you solve the square, that is 400.
Okay, so whenever you are seeing that, you are just replacing it with there.
No, what you see, what is happening over here is that you are then taking this particular part of the formula you have solved, OF minus EF squared, divided by EF. That's what you are just doing because you've already solved this. So if you solve it again here, you are going to do a double job. It's already been done here already on this particular part. What the one I'm doing a box around. You get what I'm trying to say?
Yes,
Daniel,
please.
when we got here, so when we were breaking the formula down, when we got to this particular part, this part was bracket open OF minus EF bracket close squared. So it means that this particular part of the formula, we have done it already. The only thing that we've not done in the formula was that we need to now divide this by this. OF minus EF squared divided by EF. That's what we've not done. But for EF squared, we've already solved for EF squared, so you don't have to redo it again. Are you getting me?
Yeah, right. Thank you.
Okay. Is there any more question? Can I carry on? Can I carry on?
Yes, please.
Yes.
Okay, thank you very much. So now let's move to the easiest part that we're going to deal with. That has to do with, let's now go to step number 5. Step 5. DF. DF means degree of freedom. And S square from the table. That's what we are basically going to look at. So to do a degree of freedom from the table, my table spelling crap. So it means that the formula is row minus 1 or times column minus 1. So please look at me. Where you're going to get a row and a column from is the initial table they gave you in the question. And the initial table they gave you in the question. Look at this variable. Look at this variable. The initial table that was given the question. Remember that this part was not part. Do you get me? The one I'm circling was not part. And this part was not part. Do you remember? They only gave us 20, 80, 60, 40, and this and this. Please, do you get me?
Yes.
So they're asking you how many rows and how many columns. There were only 2 rows two columns, then two rows. 1, 2, 1, 2. So here was 1, here was 2, here is 1, here is 2. So we only had 2 rows and 2 columns. Do you get me? If the numbers they gave us were like, let's say for example 3, that means our column our column would have been 3, and then the row would have been what? Would have been 2. For example, if our row was like having like they give us 3 figures, would have been 3, right? But what here the row giving us were we're giving 2, and we're giving 2 rows, we're giving 2 columns. Please do get me?
Yes,
Do you get
please.
me? Okay. So in that instance, let's go back. Let's go back to this. It means that now the row was what?
Eddie,
Yes.
he said if we were to be given 3 figures, our row will be 2 and our column, our row will be 3 and our column will be 2.
Depending on how much you are given. For example, if you are given 3 figures on the column side, that means your column is going to be 3, and if they give you only 2 figures on the row side, it's going to be only 2. So I think there is, for example, let me put this. There is, depending on how many you are given in the particular, I want to see if this question has that. So yeah, there's one question that you have on your platform. Please. There's one question you had on your platform, which was, let me just give me a minute to pull it over, to pull it up. Okay, just give me a minute. Good. So the question you had, right, is a chi-square, but it had 3, 3. So it had both 3 columns, 3 rows. So you had NDC, MPP, and CPP. So in this instance, it's going to be 3 minus 3, because the columns are 3 and the rows are 3. Do you get what I'm trying to say?
Yeah, Eddie.
But because this one we're giving only 2, it's going to be 2, 2. So it depends on the number of rows or column is going to give you in the beginning. I hope you get me. That's what will determine your degree of freedom, what you are going to subtract your row and your column from. Please do get me.
Okay. I now get you, because at first you said if they give you 3 figures, your row will be 3 and your column will be 2 instead of 3. So I was kind of confused.
If maybe my statement was not so, what I mean is that
Okay.
depending on how many columns you are given or rows you are given will determine what you are going to assign. So over here, because we have 2 rows minus 1 times 2 rows minus 1, which is going to give us what? Which is going to give us what? So the degree of freedom is going to be what? 1. 1. So now we are going to look for this 1, and from you can just go straight 0.5, 0.5, or you can just go to the table and go and look for the answer. But I'm writing this because of for you to understand s squared from the table is, so you are now going to the table to go and look for what s squared on the table is when we say it is 1. When we say 1, what is the s squared from the table? Okay, so I'm about to pause the screen, and then I'm about to take you to a different screen. So I'm just making you aware if you have any eye issues, so you're aware of that. I'm about to switch screen. So let me just do this. Share. Do you see the screen?
Yes, please.
Good. So do you see the table? So you see everything, the degree of freedom here. 1, 2, 3, 4, 5, 6. So the degree of freedom that you're going to look at is so on this side, that this column side. Then the row side is this way, right? So over here, where the 1 will intersect with the 0.5 is where your degree of freedom is. So in this instance, where does the 1 intersect with 0.5? What's the answer that we'll get there?
3.841.
3.841. Put that in mind as I move 3.841 as I move back again to switching screen. So take notice of that. So good. Then our answer is what? 3 point what?
841.
3.4 what? 8 what?
41.
841.
Okay. 3.841. So since we've done this, we are done. Step 6. CR and decision rule. Step 6. You are just writing this down just in the form to just help you in terms of your assessment. So you are writing this down. Accept HO if S squared calculated is less than S squared. This is just to help you to be able to interpret that, do the conclusion. S squared from the table. And then reject HO. Otherwise. And accept HA. I'm about to explain this thing very well. So it's a statement that is saying that at the end of the day, you see, when we were doing the one, when we were doing the one, if you remember very well, when we were doing the one, we stated two hypotheses, right? And then this thing is saying that we are going to accept HO if the S square calculated. So the S square calculated, remember you drew a table and we did a calculation. Do you remember that? Good. This what I'm about to write over here is not part. It's just to help you so that we come and do the conclusion. The conclusion that we write it, but listen. So from the table that we solved, what value did we get? From the table, what did we get? We had 3.3 point what?
34.
34. And then the one that we read from the table, we had 3.841. And it's saying that we only accept HO. So we only say that there is no relationship. We will only say that there is no relationship. If you are accepting HO, that means you are saying that there is no relationship. Do you get what I'm trying to say? Do you get me?
Yes.
I have to hear you so that I know you are following me. So I said, if we accept HO, we are saying that there is no relationship between party rating and party vote. If you accept HO,
Yes, sir.
right? So he said accept HO if S square calculated is less than S square read from the table. And over here, realize that the S square calculated is rather greater than what we read. Am I lying?
Yes.
No.
So in this instance, we are rather going toward accept HA, not HO. Because he said reject HO otherwise and accept HA. So if you turn the table around and then your HA read from the table is greater than that, mean that accept it. So accept HO if S square calculated is less than. So the S square calculated over here, the S square that we calculated over here is 33.34. 33.34 and 3.841. So what we have calculated, is it less than S square read from the table? What we calculated from the table, is it less than S square calculated?
No.
No. So it means that in this instance, HO is not true. We are rather going to what? Accept HA. HA is the right. So we are going to say that there is a relation between what? Party and region vote because of the fact that the S square that we've read from the table is what we've calculated is greater than what we've read from the table. Please do get me.
Yes. Yes.
Please do get me.
Yeah.
Eddie, please, no.
Okay, so let's go to the conclusion itself. I want to give you I'm changing the screen. We'll come back to the conclusion over here, but I'm changing the screen. So this decision rule has two things to tell you, right? The decision rule is saying that Eunice, you are going to reject HO if the S square calculated. Eunice.
Eddie.
What is the S square calculated? What is the S square value that we calculated? What did we get? What did we get? First of all, I want to know what did we get for the S square calculated? Do you know what we got?
33.34.
Please, 33 point what?
33.34.
So that is what we have calculated, right? And what was the value we read from the table? What was the value we read from the table? When we look at the table, what did we read from the table?
3.841.
Please, allow the person. I just want to get to understand her thinking. Then I know if she was following where she may have disconnected. Then I know where the issue is that she doesn't understand. What is the value that we calculated from the table? If you don't know, just tell me you don't know. Then I know where it is. And I know where you are disconnected.
Yeah, I don't know. I'm lost from step 5 to step 6.
Good. So now we know where she got disconnected. So we did were you with us when we were doing the row minus column?
No, please.
So you got disconnected. You didn't join at the point you left the class. So the degree of freedom we are saying is that you are going to subtract row minus column into row minus 1, column minus 1. And then the number of rows that was given to us in the question was 2. The number of column was 2. So the row that we had in the question was this. We didn't have this 80 and those stuff attached to it. So let me just clean it. These things were not part. In the question, what we didn't have those things that we've written here. The question, what we only had was 2080. So we had 2 row, we had 2 row, we had 2 column. That is how come we ended up writing row minus column. So the 2 row minus 1 and the 2 column minus 1 will give us what? The answer we'll get is what? Is 1. So 2 minus 1 will give us what? 1, 1. 1 times 1 will give us 1. You get it now?
Yes, please.
Good. Then we moved back to the table. Then we are going to read the table. This is the table. And we are saying that the degree of freedom is where you find it over here on this side, your column, where you have 1, 2, 3, 4, 5, 6, 7. So you're going to trace the degree of freedom as against your chi-square, the percentage that you are giving. The percentage we are giving the question was 5%. Was 5%. So 5 divided by 100 will give us 0.05. So that intersection is where you're going to have your example. That's how we read the table. So if you check very well, this is 1. And the intersection between 1 and 0.5 is what? 3.841. Do you see where my arrow is?
Yes, please.
So that is the degree read from the table. So the question is giving us two things. The degree that we have solved, which was 3.34, and the degree that we just read from the table, which was 3.841. Do you see the two now?
Yes, please.
Good. Then step 6 is saying that just Step 6, you are quoting this thing. You're just not you're not solving anything. Step 6, you're only quoting it. Quote it and just put it there. And in step 6, what you are quoting is that you're saying that accept HO if S square calculated is less than S square read from the table. Reject HO otherwise and accept HA. And we are coming here and I'm asking you that per the decision rule that we have, Eunice, the question is saying that the subset is saying that we should reject HO if S square calculated is greater than S squared from the S square from the table, the critical area. So I'm asking you that is the S square calculated from the table bigger than the one we read from the table? The S square that we calculated for ourselves from the table that we did for ourselves, and the table that we read, that one we didn't calculate, we only read it. Degree of freedom was 1. That we said it was, you just said it was 3.841, and the one that we solved, that we said was 3.341. Which one of these is bigger?
The 33.34. Wow.
So 33.34 is the bigger one, right?
Yes.
Then I ask you, do you see this thing? Do you see this decision rule? Do you see what
Yes.
read what is there?
Reject HO if x square calculated is greater than x square critical.
So S square read from the table. Let me just make it easy. From the critical table. Let me put it that way. So now I have this for you. Tell me. You said it is bigger than what you've read from the table, right?
Yes, please.
So if you so, what are we doing right now? What is this thing telling us to do?
So you have been asked to reject HO if the S square we calculated is bigger than what we read in the
on the table.
Yes, on the table.
And then is it bigger than what you read from the table?
Yes, please.
So if that is so, what are we doing? What is it telling us to do? If it's so, what is it telling us to do?
You reject it.
That's all. So if you are rejecting something, that means you are accepting the other one. Is that not so?
Yes, please.
Good. So it means that now we are rejecting HO, but we are accepting HA. So it means that what we have solved, it means that there is a relationship between party vote and region. That was what the conclusion will be. Do you get it now? So if, for example, the S square that was calculated, it was the S square that was calculated was less than what it was read. That means would have accepted HO instead and rejected the HA. But this time around, because the HO, we are rejecting it because if S square calculated is greater than S square read, so what we read 33.34 is bigger than 3.84. So it means that means that HO is not true. So we are rejecting it. So for having to solve or having to, let me take this slide off now. Let me come back. Please, this slide, you guys have to really, really follow, okay?
Eddie.
So, yes.
Eddie, please go back to the slide. Let me ask a question. No, not this one. So yeah, where the decision rule is, can I also set my decision rule in this manner, like accept HO if S square calculated is what is less than X read from table?
Yes, it's correct. The decision rule, you're just only quoting a part. So the decision rule is not, it's more like a formula, something that is standard. That's why I said, for example, somebody write that accept HO if S square calculated is less than S square from the table. Reject what? HO, otherwise, and accept HO. So the reverse. Somebody can also start with the other reverse of it, and it's okay. So therefore, the step 6, you're only writing that thing there. Oh, you can write this part. Reject HO if S square calculated is and yeah, okay. Or you can write your own. It is still perfect. There's nothing wrong with that.
Okay.
Do you get it?
So second, like where we've gotten the 33 and 33, this one, the S calculated. Let's say based on my decimal place. Can I get something like maybe 33.35 something? Is that one also correct?
We are always doing two. When we are what we've calculated from the table is always in 2 decimal places. What you calculated from the table, the working table, what you have calculated is always 2 decimal places, and the one that you are reading from the table, as in you are reading, is in 3 decimal places.
Okay, that's fine. Okay, thank you.
You're welcome.
Mm.
So, yes.
Hello, Eddie.
Yes.
So please, I wanted to ask: is there a way to calculate for the figures in the degree of freedom table? Because I don't know.
The degree of freedom table, you're not going to calculate. It will be given to you in the examination hall. Both the square table and area and the normal curve will be given to you. Nobody chooses that thing in their head. So it will be given to you in the examination hall that you're only going to read.
Okay, thank you.
Okay, you're welcome. Please, what other question again?
Eddie, let's wrap up. A lot of them are sleeping.
Okay, so now let's move straight to this. Let me go back. Stop sharing. Let me put this. So let me put this here. Good. Now, this thing part that we've done here, you are just stating it. That is all. So here, you're only stating that critical range, that decision rule. Do you get what I'm trying to say? So you can decide not to write what I've written. You can decide to write reject HO if S square calculated is greater than S square read from the table or the critical area. That's all. That one too is correct. Do you get me? Please, do you get me? Hello, please, do you get me?
Yes.
Eddie, please come again.
No, the whole show.
What I'm trying to say is that in step 6, if you are just writing it down, nobody's asking you to interpret anything. Step 6, you're not interpreting anything. You're only saying what is going to inform your conclusion. By my conclusion, if HO is what is HO, I'll reject HO if S square calculated is greater than S square read from the table. Simple. Or somebody will say that, oh, I will accept HO if S square calculated is less than S square read from the table. Simple. Or otherwise, the person is done. So step 6 is just a grammatic sentence you are putting there. Do you get what I'm trying to say?
Yes.
So it's not anything you are solving or anything. It's just and it's in your slides. So it's just a statement you are repeating there. That okay, if this is to happen, that means this is what we're going to inform my conclusion. That's all. So even in the initial thing I was doing, I even removed step states, but I realized that because that step state was written in your slides, and you're going to use that for examination, I decided to just keep it there. Because some people already have it in their head, so they don't write step state. They go straight to the next one because they feel like this one that's what's going to inform them, so they know. But for you to understand how the step 7 is coming about, that's the reason why you are writing it there. It's just a English word that is there. They are writing there that okay, if this happens, I'll do this. If this happens, I'll do that. Are you getting me?
Yes.
Yes.
So what I'm going to write, my conclusion will be that since S square calculated, which is 3.34, since S square calculated, since S square calculated is 3. 33.34 is greater than S squared from the table, read from the table, which is 3.841, we reject HO and we accept HA. Therefore, there is a relationship between region and party vote at 5% level, and that's all. You are done. So step 7. Step 7 is saying that's the conclusion. You can write on top conclusion. Step 7 is saying that since Uni said that S squared calculated, and all of you agreed, the S squared calculated, which is the 3.34, is greater than S squared critical, which is 3.841. We reject and accept HA. So this is therefore, this dot I've done there is therefore. So therefore, there is because we don't have enough space, I'm cutting something short. There is a significant what? Relationship between region and party vote at the 5% level. Please, you get it? Please, you get it?
Yes, Eddie.
Yeah, Eddie.
Okay, so because time is fast spent, we are supposed to go through the crosstab analysis that you guys wanted me to go over again. I'll do that for you guys. And then we still have 2 questions to look at under this. But for this particular lesson, I'll bring it to an end over here, and then